the crossfire. It's caught in the crossfire.
Hi mga ka-CHEME! Welcome to our third vlog, which is entitled, What is pH? At the end of the experiment, you shall be able to demonstrate how to measure pH of a solution. Number 2. Compare the accuracy of a pH indicator and a pH paper. Number 3. Calculate the pH given the concentration of hydrogen or the concentration of hydroxide.
Concentration of ions, especially hydrogen and hydroxide ions, can be mind-bogglingly small in a solution and can even reach 10 raised to negative 7 in concentration. That is why Sorensen proposed the idea of pH. pH is the negative logarithm of hydrogen ion concentration or the hydronium ion concentration. It can range from 0 to 14, with 0 to 6 being acidic, 7 being neutral, and 8 to 14 being basic. If we would to extract a pH of 4 into hydrogen ion concentration, we would arrive at 1 times 10 raised to negative 4 molars. Also, take in mind that while pH decreases, hydrogen ion concentration increases, or acidity increases. pOH also works the same way. However, the lower the pOH value, the greater the hydroxide ion concentration, and more basic the solution is. A pOH of 7 is also neutral. Now, how about we test some solutions and determine their pH, to know if they are acid or not? In this experiment, we will use various pH testing tools. These are litmus paper, pH paper, indicator dies, and the pH meter. Let's go! As we can see in water 1, there are no changes in color in red litmus paper, as well as in blue litmus paper. This only means that the water solution is neutral. In water brand number 2, red and blue litmus paper doesn't show any changes in color. That means the solution is neutral. Also in water 3, Both red and blue litmus paper doesn't show any changes in color, and that means the solution is neutral. Water 4 doesn't show any changes in color in both red and blue litmus paper, and it is also neutral. In the evaporated milk solution, red litmus paper doesn't show any changes in color. However, blue litmus paper turns into slight pink and violet, and that means that the solution is slightly acidic. For the liquid soap, red litmus paper turns into blue. However, blue litmus paper doesn't show any changes in color. That means that the solution is basic. For the soda, in red litmus paper it doesn't show any changes in color. However, in blue litmus paper it changes into red. That means that the solution is acidic. For the tea, red litmus paper doesn't show any reaction. However, blue litmus paper turns into red. That means that the solution is acidic. For the last solution, coffee, red litmus paper doesn't show any reaction. Blue litmus paper, however, turns into red. Just like the previous solutions, it is acidic. For the next tool, let us use pH paper. pH paper, unlike litmus paper, can turn into various colors, which we can compare to the table given to know the specific pH of the solution. As we can see, the color reaction for water 1 is lime green, which means the pH is 6. Water 2, 3, and 4 are also consistent with the pH of 6. This is observed because the color reactions are all lime green. The color of the pH paper observed in tea is yellow, which means that the pH is 5. For coffee, the color is lime green, which means the pH is 6. Milk has also the color of lime green, which has the pH of 6. In this test, we are going to use 4 indicator dyes, namely phenolphthalein, bromothymol blue, methyl red, and Congo red. Phenolphthalein turns colorless in acidic solution and red in basic solution. Bromothymol blue turns colorless in acidic solution and it turns yellow at pH 6.0 and turns blue at basic solutions above 7.6. Congo red turns blue at pH below 3.0 and turns red at pH above 5.2. Methyl red turns red at pH 4.4 and turns yellow or orange with a pH of over 6.2. For the H2O1, it turns colorless in phenolphthalein, it turns red in Congo red, and it turns yellow-orange in bromothymol blue and orange in methyl red. This indicator shows that water 1 is neutral. Water 2, 3, and 4 is consistent with H2O1, with having colorless in phenolphthalein, red in Congo red, yellow-orange in bromothymol blue, and orange in methyl red, which means all of them are neutral. For coffee, phenolphthalein stayed colorless, Congo red turned red-orange, bromothymol blue turned green, while methyl red turned orange. The color orange in methyl red and color green in bromothymol blue indicates that coffee is slightly acidic. Liquid soap has colorless phenolphthalein, dark red Congo red, dark green bromothymol blue, and orange methyl red. Though phenolphthalein has turned colorless, the dark red and the dark green indicates that the liquid soap is basic. Surprisingly, milk has similar results as of water 1, 2, 3, and 4. It has colorless phenolphthalein, red Congo red, yellow-orange in bromothymol blue, and also orange in methyl red, which means milk is slightly acidic but overall neutral in nature. For the soda, it turned colorless in phenolphthalein, red to dark violet in Congo red, orange in bromothymol blue, and red in methyl red. The red color in methyl red and the red to dark violet color in Congo red indicates that the soda is acidic. For the water brand 1, we obtained the reading of 6.93. For water 2, the pH is 5.44. For water 3, it is 5.59. For water 4, the obtained reading is 5.57. The coffee has the pH of 6.33. For the liquid soap, the pH is 8.74. Milk has the reading of 6.40, nearly neutral. For the soda, we obtained the reading of 2.98.
So what's up mga ka-CHEME? Have you learned something on our experiment today?
See you in our next experimental journey.
Thank you for watching! Bye-bye!
Bye-bye!
Like
And subscribe!
Bakit tumuturo ka dito?